Well, good morning to you. Good morning to you. There we go. All right, everyone. Welcome to another episode with Math by Audrey. I'm wondering if you can answer this particular question in 30 seconds. So this is the function of x is equal to 4x minus 1. We need to find the function of negative 2. So as soon as the time expires, you can put your answers in so we can break down these concepts. So for those that don't know, my name is Audrey Codner. I'm the owner of Math by Audrey, and I do online tutoring and also math resources to help people. All right. So if you have your answers to this, go ahead and put it into the chat. We're going to give myself a little bit of space so I can break down these concepts. Now, if you are like, I have no idea where to start, not a problem, because guess what? I'm going to break down these concepts for you. So you can actually feel a little confident, a little freeing, so we can get all this in there. All right. Hey, Clunky Cakes, how are you? Welcome back. All right, so Clunky Cakes is saying my -9. All right, any others? Because we're going to see how Clunky Cakes got this. All right, so if you notice, we have the f of x is equal to 4x minus 1. So we're looking for the f of -2. Notice that -2 and x are in the same space. So as we're looking for the f of -2, we're simply plugging in or substituting the x with our -2. All right, x, I see you. So we have 4 times -2. That gives us a -8. So we're doing the order of operation. Bring down your -1, and -8 plus -1, that gives me a -9. So that means the f of -2 is equal to -9. So we're not doing anything to the left-hand side. This is just to remind you what you're substituting in for x. Because the ultimate goal is you actually found an ordered pair. Here's your x, which is -2, and here's your y, which is a -9. This is going to be a point that's on this line. All right, so that's what you're basically looking for. All right, so let's try this one. See if we can solve that in 30 seconds. Okay. So if you're seeing some stuff and you're like, ooh, I don't remember that, it's okay. Once the time expires, go ahead and put a question mark in, okay? So make sure you're holding your answers until the end of the time, so then we can actually break a lot of these concepts down. Hold your answers until the end of the time. Thank you. Seriously, hold your answers. All right. Okay, now let's put up your answers. Okay? Learning a little bit of discipline, my loves. A little bit of discipline. Okay? All right, so we have a 009 with our n to the 6. Clunky, we had n to the 6th power. Matt, we had n to the 6th power. August, oh, it's your mom. You have n to the 6th power. Omar, you had n to the 6th. Okay, there's some people. Martin, oh, Martin, you're back. Oh, yeah, n to the 6. Pooh squared, you also had your n to the 6. Okay, and Tis, I got you. All right, so n to the 10th power. I know it gets kind of crazy. Let's see if I can bring it down here. So n to the 10th power is saying the job of the exponent is telling the base how many times it's going to multiply itself, Right, there you go, gringo. Right? So then, my denominator is saying that I have n to the fourth. So that's saying how many times I'm going to multiply that base of n, which is 4 times. So then when you do your division, that turns to a 1, because anything divided by itself turns to a 1. Or otherwise as canceling out. Because 1 times 1 times 1 times 1 gives us 1. But after I do that simplifying, I have some n's left over. So I have 1, 2, 3, 4, 5, 6 n's left over. So we can do what's called the expanded form. And if I'm doing 6 n's, that gives me n to the 6th power. Or we can remember this. So there's a property of exponents called, when you are dividing, it's the quotient rule. And it says if you have the same base and you are dividing, you just have to subtract the exponents. So you keep that same base, and all you're doing is taking your 10 minus your 4. And then 10 minus 4 gives me 6, and you keep the same base. Alright? So, instead of doing this long extended, the reason why I did this, so now you got a visual. But that's basically what you're doing. You're keeping the base, and you're subtracting the exponents. Okay? Am I using my left hand? No. Interesting. Alright. Okay. So, let's try this. Factor that. 30 seconds. Hold your answers until the end. Because I like to give you guys recognition. Alright? Come on. Who doesn't like hearing their name on social media? You're like, oh my god, that's so me. They see me. In our case, when the bases are different. Yes. So when the bases are different, you can't combine them. Okay? You can't combine them. I'll show you after this one. Okay? Alright? Hold your answers until the end. Okay? Go ahead and flash up your answers. Know how to do that. Sorry, not a problem. I'm here to teach it to you. Okay? Alright? Okay, Chunky, I see that. No problem. Hector, how are you? Alright. Okay. Jude, I see you. Alright. Mona, I forgot. I got you. Ollie, alright. Let's see what else we have. Okay. There we go. Alright, so let's take a look. So we got a lot. Yep, I'm going to explain. Keep your panties on. It'll be alright. Alright. So, when you factor, it's like doing the distributive property in reverse. Our leading coefficient, the number that's in front of the highest degree. My highest degree, a degree is also known as an exponent. So this is my highest exponent. What this is has an exponent of 1. So that means the number or the coefficient in front of the x is my leading coefficient. If my leading coefficient is 1, I can go right into splitting my x's. And the reason why I have 2 parentheses is my highest exponent is to the 2nd power. That means I'm going to have 2 roots, 2 zeros, or 2 solutions. So here I'm going to split my x's up. Now this is the part that usually gets a lot of people. I like to draw an x. So for me, I need to know what 2 numbers multiplied will give me 15 and add together to give me that middle term of a positive 8. So what 2 numbers multiplied together will give me 15 and add together to give me 8? Yes, we have 3 times 5 gives me 15, and 3 plus 5 gives me 8. These two numbers right here is going to be the completion of our two factors. Since they're both positive, you're going to have a positive 3 here and a positive 5 here. Now, there is no equal sign here, so we're not solving. This is when you stop. Okay? So these two are your two factors to give you your original expression. Okay? So where did the exponent went? Right here, because x times x gives me x squared. Alright? So if you want to check it, which during the test, it might not have too much time. So if I did my distributive property, this is for me checking, x times x gives me x squared. X times 5 gives me 5x. Then I take my positive 3 and I distribute it to the second parenthesis. 3 times x gives me 3x. Plus 3 times 5 gives me 15. Like terms are right here in the center. 5 plus 3, that gives me my 8x. Plus 15. And since it's a positive 8, you got your plus there. And x squared. Notice these two are exactly the same. Okay? Alright? Okay? Right. So, if you wrote down x plus 5, then x plus 3, that's fine. Okay? Because with multiplication, it's commutative. Same thing with addition. That means if I said 3 plus 7, or 7 plus 3, you'll get the same result, which is 10. If I said 2 times 5, or 5 times 2, you get the same result, which is 10. Okay? So it doesn't like, oh man, I don't know which one goes first. Doesn't matter. Okay? Sweet. Alright. So, someone asked, what happens if, when we did the exponent problems, what happens if we had two different bases? You can't combine them. Okay? You can only combine if they have the same base. If they have the same bases, I would subtract 5 minus 4, so I have my base. Then you have your 5 minus 4. 5 minus 4 gives you 1, so your answer would just be x. Okay? When they're not the same bases, we can't do anything about it. Alright? So let's try this one. Okay? Simplify. Okay. No, the first one would not be 1. If they don't have the same bases, that's it. It's prime. You can't break it down any further. But if 5 minus 1, that does give you an exponent of 1, but anything raised to the first power is itself. Anything multiplied by 1 is itself. Anything divided by 1 is itself. Okay? Alright. So, square root of 108. I didn't see too many answers. What's going on? Let's go. What do we have? Okay. Yep, the bases were different. Alright. So, okay, I don't know. Alright. Teach topic in pure math? No, I do not. I forgot who answered that. Yeah, King, that's not me. Okay, so we have Matt with a 9. Okay, you don't know this? Gotcha. I'm going to break it down. Okay, Macy, hey. Hems, okay. I see you. All right. Now, when it comes to breaking down square roots or simplifying square roots, first off, we need to know about our perfect square roots. So what makes a perfect square root? So we got square root of 1, square root of 4, square root of 9, square root of 16, 25. Okay, you can see this. Square root of 36, square root of 49, square root of 64. I'm going to hold it for right here. So, the square roots are the inverses of squares. So there is a number, if you square it or multiply it to itself, will give you the results that's underneath the radicals, which are called radicands. So I know 1 squared will give me 1. So the square root of 1 is 1. I know that 2 squared will give me 4. So that means the square root of 4 is 2. And I know we're going to do a plus and minus, but right now, let's just work on the positive, the whole set. So the square root of 9 is 3 squared will give me 9. So the square root of 9 is 3. 4 squared will give me 16, so that's 4. 5 squared will give me 25, so that's 5. 6 squared will give me 36. Here's my 7. Here's my 8. So in order for you to break down the square root of 108, you need what's called a perfect prime combination. Okay, we're looking for a perfect prime combination. We're looking for 2 numbers. Okay, 2 numbers when multiplied will give me my 108. So, knowing that lovely trick, that's one of the reasons why I designed my factor sheets. Because some of us are not that strong when it comes to our multiplication. So, especially if you're taking the test, you have the Accuplacer as well as the ASVAT, you can't use a calculator. And most factor sheets only go up to 100. But what happens if you deal something with a larger number? So when we talk about 108, we have 1 and 108, 2 and 54, 3 and 36, 4 and 27, 6 and 18, and 9 and 12. So in order for us to get the square root of 108, we need to see which factor will be perfect and prime. First off, what's a prime number? So a prime number is factors are only 1 and itself. So 1 can't be a factor of itself. Alright, so that's why 1 is not a prime number. The first prime number is 2. So if we take a look, okay, if you try to do 9 and 12, 9 is perfect, but 12 is not prime. Okay, I can get 12 by multiplying 1 and 12. I can get 12 multiplying 3 and 4, 6 and 2. Alright, so 12 is not a prime number. So your perfect prime combo is going to be the 3 and the 36. There you go. Because 36 is a perfect square root, which gives us 6. And 3 is a prime number because the only factors of 3 are 3 times 1. That's it. You can't get 3 any other way through multiplication. So now we need to break this down. We have our perfect, which is 6. So the square root of 36 is a whole number of 6. And since we have a prime, square root of 3, I can't break this down. So if I can't break it down, I'm simply going to bring it down. So my answer is going to be 6 square root of 3. Now, if you showed me the decimal version, you're not giving me the exact value. you're giving me the approximate value. So there's going to be times that you're going to have to read the directions of any of the tests to see if it wants it to be exact or if it wants to be approximate. Okay. All right. Hey, MT, how are you? Okay. All right. Okay. Questions. All right. Okay. Hey, Apple user, how are you? Okay. Well, no joy? Hey, that's fine. But here's my thing. If you are going to say anything, make sure you put your picture up. Let people know you. It's okay. Okay. Okay, you need a clarification on a simple matter? Alright, good. Absolute would be the decimal. What do you mean? The absolute? So the approximate will be the decimal because you're rounding. Alright. Alright, so let's take this one. Let's try this one. Okay, tell me my slope. Tell me my slope. Can I solve an equation? Not sure. 6 times 4 isn't 25. Take a look at your thing. Alright. Okay. So we have Chevs, I see you. Cheese.com, I see you. Okay. Go ahead and put your answers in. Let's see what you got. Okay, right now I'm doing what I would like to do, which is teach. So I got this. You forgot this math? That's okay. I got you. Okay, shows you're switching. Okay. Alright, point 4. I see you. Alright. So, let's break down. Alright. So let's take a look. What we're doing is when we're finding slope. Otherwise, it's really the rate of change. It's like how steep your line is going to be. So when you do, some people read from left to right. So since this is the first point, and my points are always labeled as X and Y. So since this is the first point, I'm going to label it as my subscript of 1s. This is my second point. That's my X and my Y's, and I'm going to give them the second point of 2's. So when you find slope, you can do the y sub 2 minus the y sub 1 over the x sub 2 minus the x sub 1. Okay? So once we get our information, we're looking at the changes of our y's over the changes of our x's. Okay, now you're getting it? There we go. I know it's going to click. So we have our -1 minus my y1, which is 5, over my x sub 2, which is 6, minus my x sub 1, which is 3. Now we're starting to see it. Okay. So now we have a -1 plus a -5. Hear how I'm saying it, because a lot of us keep thinking that you're minusing. Now that we are going to combine these two numbers together, that minus is now a negative for the 5. So when we combine, we have negative 1 plus negative 5. So say that I gave you $1. Okay, so you owe me $1, and for some sick and twisted reason, you asked for $5 and I gave it to you. That's the reason why now you owe me $6. That's a negative 6. There we go. So now we have 6 plus a negative 3. I had $6 and I spent $3, but I still have $3. So yay. Now we have negative 6 over 3. So we can do the division. So we can simplify this. So negative 6 over 3, that gives us a negative 2. Okay? So for some people that were giving me 3s and 2s, do we see what happened now? Okay, good. All right. So here's the other thing. This is the general mistake a lot of people make. They do the y2 minus y1 perfectly fine, but then they go to x1 to x2. I don't know why our brain does that, but it does it every time. So then it would give you a negative 3, and then you would have gotten a positive 2. So this is why sometimes I like to do math this way. I read it the way that I normally read. So I go from left to right. So I have my y1 minus my y2 and my x1 minus my x2. So I go left, right, left, right. So this would be my 5 minus a negative 1 over my 3 minus 6. So when you minus a negative, remember it's going to turn positive. So it's really going to be 5 plus 1. And this still remains as 3 minus 6. So 5 plus 1, that gives me 6. 3 plus a negative 6, because that's what's happening. So if I had $3 and I want to spend $6, that means I am short $3. So 6 divided by negative 3, it still gives you a negative 2. Okay? Alright, it still gives you a negative 2. Alright, let's go. Alright. Okay, let's try another one. Try to solve that. 30 seconds. Okay. All right. If you have time to graph it, that's fine. Okay, but we're just going to take things step by step, because sometimes you don't have a graph. And sometimes when you take these tests, you're not going to have a calculator. Okay. All right. Okay. Go ahead and display your answers. What do you think is going on here? Okay, Mala, I see you. Okay, Joseph, I see you. Okay, All Things, I see you. Kanie, I see you. Okay. Alright. So cheese.com, don't stress yourself out. My thing is, this is going to be a safe space. The more he comments, the more he's making this live relevant. But you know, and you stay true to what you need to do. Okay, thank you, Cheese. Okay, Liberal, I see you. Luke, I see you. Natural, I see you. More Hair Salon, I see you. Okay. Alright. This is fine. There we go. Okay, so let me keep you guys safe. Because I'm not sure what's his intent, so I'm going to keep you safe. That's the best that I can do. Okay, so if you're not sure where to start, change your answer. Okay, all right, Star Girl, how are you? Okay, if you're not sure, put a question mark in the chat. That tells me how far do I need to explain. Okay, all right, PJ, thank you so much for your honesty. Ah, Shucky Ducky, thank you so much for your honesty. I appreciate you. Welcome back. All right. Okay, Craig, thank you for your honesty. Appreciate that. Okay, Abba, oh, love it. Okay, Max, hello, Max, welcome back. All right, so I know what's freaking you out is we have an x. Well, this x is supposed to represent multiplication. So let's take it step by step. So let's come here. So we have a base of y to the fourth raised to the second power. There you go, Justice. Appreciate that. So basically they're saying that we have this y to the fourth and it's being multiplied to itself twice. And when you multiply, we add the exponents. Now here's a shortcut for this. When you see an exponent being raised by an exponent and being separated by a parenthesis, you multiply the exponents. Okay, 4 times 2 also gives us 8. So instead of writing this expanded form, you could just go ahead and multiply the exponents, right? Okay, so there's nothing in front. But now, they want us to take this answer of y to the 8th and they want us to multiply it by y. Okay, so y to the 8th raised to the first power. So if you don't see an exponent, it's a 1. And like we did up here, when you multiply and they're the same base, you're going to add the exponents. Well, the same thing is happening here. There you go. All right, you're going to add the exponents. So it'll be y to the 9th. Okay, how are we feeling? So when you multiply, you add the exponents. When you divide, you subtract the exponents. And if you have an exponent raised by an exponent, you multiply the exponents. Okay, make sense? Okay, thank you, Overdose, for the love. Appreciate it. PJ as well. No problem, man. You're feeling old? Don't feel old. I'm like, people, there are times I have people in here that are the lovely age of 75 doing some math. Okay? All right, thanks. All right, now, let's see for this one. You're like, oh, Audrey, this is where you went crazy. All right, so I'm not going to put a timer on this one. Okay, yes, math does have a lot of rules. Okay, we're going to graph this. Now, we have y equals 1/4 x minus 1. Don't let the fraction freak you out. Okay? This is what is exactly happening. This is what's called slope-intercept form. So slope-intercept form is usually y equals mx plus b. You need two things. Anytime they say do the equation of the line, you should be thinking this. The two things that it's giving you is your y-intercept okay, and the other name for y-intercept is your starting point. and it's where it intersects the y-axis. So the y-axis always goes vertically. Okay, it's basically two number lines intersecting at a common point of 0. Right? Now, your m, that's your slope, or your rate of change. Okay? We love to say rise over run. You gotta rise out of bed to run to the bathroom. Trust me, when you get to 50 plus, you'll know what I'm talking about. Okay? So, this is how you start. And I think a lot of this. For my Don, okay, alright. So this is where you start. You take a look at what would represent your B, your y-intercept. So my y-intercept, thank you, Cher. Got you. Alright. So your y-intercept is that -1. That's where you start. So here I am on the y-axis. Here I'm at 0. Here's -1. That's where my first point goes. Okay? Now, once we finish with the y-intercept, your starting point is no longer at the 0. It's going to be at -1. But your slope, which is the 1/4, that's giving you direction. And here's the thing. You want your slope to be a fraction because we have rise over run. So that means our rise, which either you're going up or down. If it's positive, you're going up. If it's negative, you're going down. And your run is from left to right. If it's going to the left, it'll be negative. If it's going to the right, it'll be positive. So starting at -1, my slope is 1/4. So that means I'm going up 1. Okay, don't make a point. We're just going to go up 1. And then it's a +4. Then you're going to go to the right 4. Now you plot your point. Okay? That's basically it. All you have to do now is draw your line. Ta-da! You just graphed a linear equation. Okay? That's all it is. Nice, easy, relaxed. So this is how you graph an equation, especially a linear equation. So they give it to you, especially if they give it to you in what's called slope-intercept form. You start at the constant. So let's say, just throwing this out there, let's say, oh wait, Audrey, what happens if the equation looked like this? Like it was flipped around. Well, your y-intercept normally is at the end, but the y-intercept is the constant, the one that doesn't have an x or y next to it. So they just flipped it around. This is still going to be your y-intercept, your b, or some places say your c. And the number that's next to the x, adjacent as we may use, okay, that's going to be your slope. So they can flip it around all they want. You're going to start at -1, boom, that's your first point on the y-axis. Then you're going to look at your slope. You're going to rise up 1 and go to the right 4. +1, +4. Up 1, over to the right 4. Done. Okay? What if it's not a fraction? Dulce. I love it. Okay? Let's try one. Why not? We can do whatever we want. Let's try this one. So we have y equals -3x minus 3. Alright. So if we recall, we have our slope-intercept form. So we have our y equals mx plus b. Okay. What's representing my b is my starting point, -3. So I start here at my 0, but I'm going to go down to -3. I'm going to plot a point. That's my starting point. Now my slope is a -3. But we're saying that we need it to be a fraction. So how can I make this into a fraction without losing its value? I'm going to put it over 1. Okay, so just the m is going to be your slope. Yes. So anytime you have a whole number that's adjacent to your x, we're going to make that into a fraction by putting it over 1. So from your starting point, not the origin, you did all that work to find the starting point. So from this starting point, you're going to follow what they give you, -3. So that means I'm going to go down 3, and I have a positive 1, and I'm going to go to the right 1. So starting at my point, going down 3, 1, 2, 3, to the right 1, plot my point. Okay, feels like you're in school? Good, because I'm a teacher. I hope you have that feeling. Hopefully it's a good feeling, not like, oh, I'm about to lose my mind. All right? So now, here's another thing, playing devil's advocate, because you know, I'm a Libra. So, even if they give you a -3, and say for, I don't know, for giggles, that you went counting down 3 and you were completely off the graph. You're like, oh God, I can't even graph this. So this is the best thing about negative slope. The numerator or the denominator could carry the negative. Meaning, I can make this 3 over -1. So before we had the 3 that was carrying the negative, now I'm going to switch it and have the 1 carry the negative. So that means from my starting point, I'm going to go up 3. But since it's a -1, I'm going to go to the left 1. So from our point, starting point, -3, go up 3, 1, 2, 3, and over to the left 1. Notice that point is following suit, so I can make my nice straight line. And try to go through most of the points. I don't know where my ruler is. So, using a pencil. That's what they used to do back in the day. Alright, so when there's no fractions, we always add a 1, yes, underneath. Yep, no matter if it's a negative number or a positive number. There you go. You got it! Alright, so anytime you have a whole number. So this is how you basically graph your fractions. Alright, so let me challenge you a little bit. Hopefully this is going well. You always go the opposite direction. What do you mean, Anthony? See, I was good, and then all of a sudden you said so. That's good. Math. Oh, good. Very nice. Nice. Anthony, tell me. I always hated it. I know. I think you always hate how it made you feel. Because this is why I teach. Because I didn't have good teachers when I was growing up. To finish the plot, you follow the direction of your slope. So it's almost like, here's your home. Your home is at -3. And you're giving somebody directions to the party. Okay? Say that there might be 2 different parties. So it depends on what party you want to go to. So you're giving direction. You can go down 3 city blocks and then turn right 1 block. Boom, there's the party. Or you can go up 3 city blocks and turn left, and boom, you can go to that party. Okay? Yep, so whatever the slope tells you to do, that's your movement. Okay? Your y-intercept just tells you where to start. Okay, that's the opposite direction because it's what? A negative slope. Okay, you don't always have to go the opposite direction. Remember, you just basically need a minimum of 2 points to make a straight line. Alright? Okay? Alright, yes, M is your slope. Yard, guess what it is. M is your slope, is your rate of change. Alright, so let's expand and let's do some translating. We haven't done that yet. Okay? No problem. Because I know you're in a culture where it's not used to a woman. Okay. I get it. I get it. Alright, so let's translate this. Let's see what we got. Let's translate it. We should be able to get this done in like 30 seconds. Easily. Okay, let's translate this. Okay, 7 more than the product of a number and 8. How do I translate it from verbal to algebraic? Okay. 7 more than the product of a number and 8. Alright. Alright. Go ahead and try to put your answers down. Now, here's the thing. If you feel you're just like, I have no idea where to start, put a question mark. Okay, that kind of helps me to say, alright, I need to take my time with this problem. Okay, so put your answers. What do you think it means? Okay, what do you think it means? That's okay. I've been called worse. Yeah, all woman here, all woman. Okay, Abba, appreciate you. Dos, okay, I got you. Dolce, I got you. Okay, thank you for your honesty. Okay, it's God's child. Hey, thank you. There's just something missing, God's child, but we got you. Okay, Star Girl, got you. Ale, got you. Okay, no problem. Big Al, how are you? Okay, got you. Okay, I'm going to break all this stuff down, so don't feel bad if you're like, I don't know. Because I know our struggle is with word problems. I know that. So let me try to alleviate some of that stress so we can break these concepts down. Okay? All right. Okay, you see it? Okay. So 7 more than the product of a number and 8. We have 2 operations going on here. Okay? All right, not a problem. Theo, welcome in. You're late. That's okay. So, more than. More than is not the inequality sign, you know, with the alligators and all this other stuff. No. That's when it says is more than. More than, just that expression, means addition. So we're going to add something. But what is going to be more than? So 7 is going to be more than. That means 7 is going to be the one to carry the addition sign. But what is 7 going to be more than? That's where this expression here comes in. The product of a number and 8. So we need to know what product means. Product means multiplication. So what are we multiplying? Usually when you're multiplying 2 numbers. But what are those 2 numbers? That's what's happening here. We're multiplying a number and 8. So I'm multiplying a number and 8, which would be like, x times 8. Or we can simply write it as 8 times x as 8x. We're used to seeing it that way. There you go, Yang. Good. All right. So since 7 is more than, we have to switch it. For the 7s, for more than and for less than, you always have to switch what you're doing. So if we're saying 7 is more than or 7 more than, that means it's going to be an addition of 7 to something. And what the something was, the product of a number and 8. So 8x. All right. So now let's take this to the next level. I know. people that come on my lives, I don't know if you get excited about it or not, but I do. All right. So I have four choices here. Choice 1, 2, 3, or 4. Which one do you want? Just put a number in. 1, 2, 3, or 4. Okay. 1, 2, 3, or 4. All right. So we got some 3s, we got some 2s, oh 3s, close. Oh, got a couple 4s. Okay, let's see, 2 more people. Oh, got a 4. All right. Oh, okay, 4 is now tied with 3. Oh, 3's in the lead. We got 1. We got another 3's in the lead. Who's the tiebreaker? Big Al saying 4. Okay, at least we know not 1. All right, so it looks like 3. Let's try it. You're like, ah. All right, so we're going to extend on this. So we have 7 more than the product of number and 8, so we did that. Is at least -3. How would I say is at least -3? Ooh, how would I translate that? Try to put it in the chat as best as you can. Because I know some people are like, I wish I could. Okay, try to put it in as best as you can. So you're saying equals -3. Okay, is at least. You have greater than -3, Theo. Okay, something is slightly missing. Okay, very close. All right, Ashley, I see you. Okay, greater than or equal to. Thank you, Random. Okay, Sherry Collins, I see you. Abba's beloved, I see you. Okay, Jonas, I see you. Okay, we're gonna work on Jar. Okay, Shucky Ducky, I see you. Big Al, I see you. Close, you're having a brain fog. That's okay. Relax. Okay, relax. It's not on my phone. I know, I get you. Alright, so let's try this part. And we're going to add it to what we just did. Is at least, okay? Is normally means equals, but it says at least. At least, so if I want to say, I want to at least make, $25 today. So that means I'm saying $25 is going to be the minimum I want to make today. I don't know, I'm just reaching. But if I make $100, I still hit my quota, because I want to at least make $25. So that means if I make $25 or more, I'm going to reach my quota. So the at least part means greater than or equal to. So think of it this way. When you see at least, think the opposite. It's going to be greater than or equal to. Greater than or equal to what? -3. Okay. All right, so we're seeing that. So a lot of times it is that translating. Certain words carry certain phrases. So now that we're here, we got this part. Let's solve this bad boy. Let's solve this bad boy. So we want to get x by itself. What's the first thing I should do? What's the first thing I should do? Okay. Oh, thank you so much. Was I grateful? I appreciate you. Okay. So Big Al subtracting the 7. Random subtract the 7. Okay. So divide by 8. All right. Cross multiply. Break out. -7 or subtract the 7 on both sides. God shall say net -7. Okay. When you're solving, the goal is to get x by itself. So that means we're going to keep this 8x right where it is. We're going to keep that. So in order for this to be by itself, that means we need to get rid of that +7. And how do we get rid of a +7? Do the inverse, which is subtract the 7. Okay? +7, -7 will give me a 0. But I don't need the 0. Okay, the reason why I don't need the 0 as a placeholder is I still have that 8x. Greater than or equal to sign comes down, -3 and the -7. I'm going to combine them. When I combine, I add. So that means I have a -3 plus a -7. I'm just putting myself deeper in debt. Okay, so that will give you your -10. Okay, good, Theo, I see you. Good, Random, Yar, good. Abba, good. So now what should I do? I want to get x by itself. What should I do now? There you go, Theo. There you go, Grateful. There we go. Yours, we're already there. Good. Random, good. Okay, we're going to break it down. Big Al, I see you. Star Girl, I see you. We're going to divide. Yes, there we are, Shar. There we go. We're going to divide both sides by 8. Okay, 8 divided by 8 will give us our 1. 1x and x means the exact same thing. So now we have -10 over 8. If I divide this, this is going to give me a lovely little decimal. Let's keep it as a fraction. I know, you love it. So it's still going to remain negative. What number does 10 and 8 have in common? What number does 10 and 8 have in common? There you go, Gaggles. I love it. Okay? It's going to be 2. So let's divide by the number that they both have in common. You can see an 8 and a 10 in the 2 times table. So then 10 divided by 2 gives us the 5. And the 8 divided by 2 gives us the 4. Alright? There we go. And we make sure we keep it negative. Because a negative divided by a positive, your answers are always going to be negative. But notice I didn't draw the inequality sign. This is the only thing that's different compared to an equation. When you have a greater than or equal to, and take a look, we divided by a positive 8. So when you divide by a positive number, your inequality sign does not change. Okay, it's still going to remain as greater than or equal to. Even though our result is a negative, that's not why you flip the inequality sign. That's what gets a lot of people. You flip it when you multiply or divide by a negative number. That's when you change the direction of the sign. Okay, when it's negative. There you go. Yep. Yep, and Yar, you can do that as well. It's a mixed number. Okay. Alright. Let's do another one like that. That was fun. Okay, translate this. Okay, no problem. Translate this. Okay, sorry, it's like 17 seconds. All summer, no math, I know, right? Alright. Okay, write down what you think your answer should be. The difference of a number and 23. Okay, the difference of a number and 23. What do you think? What do you think is your answer? Okay, so Theo, I see that. Okay. Alright. Okay, don't confuse yourself, Theo. Don't confuse yourself. Alright. So Star Girl, I see you. Always go with your initial instinct. What felt good. Don't let your brain throw you off. Alright. Thank you for your honesty, Dolce. Okay, Shucky Ducky, I see you. Okay, don't be afraid. If you think you know it, put it in. If you're not sure, put a question mark. Okay, I'd rather you say, just take that first step. I'm not here to make fun of anybody. I think most of the trolls finally left, and it's only the people that want to learn are sitting right here. Okay, so we're going to learn from our mistakes. We're not perfect. We did not come out the womb learning this. I know I didn't. Okay, I did not have math on my future at all. That's God. He wanted me to do this. Trust and believe. Okay, Dee Dee, thank you for your honesty. Okay, okay. Goofy, thank you for your honesty. I see you. Shar, I see you. Yar, I see you. And thank you for asking that question. All right. Does difference mean subtraction? Yes. So if you're taking the difference, when you want to do a comparison, okay, so say I want to compare my pencil and my pen. The first thing that we do is we always look at the difference. Okay, this one has an eraser, this one has a click top. So we're basically taking out what they don't have in common. That's just our natural instinct. So when we're looking at the difference of a number, so you want to use n, you can use x, whichever you want. We're not flipping anything around. The only time it flips around is when we say less than or more than. So now, decision time. All right. Here we go. We either got 1, 2, 3, or 4. Which one would you prefer? Okay, 1, 2, 3, or 4. Difference means subtraction. Alright, so we got a couple 1s, got a couple 2s, got 1 4. Let's do 1. Don't feel bad. Okay, so far the 1s are winning. Okay, let me see, two more answers. We got 4, we got 2. People are like, I think I can see it. We got 4. Up, Dolce got it. Alright, so we're going to add this part. Is greater than 76. Ooh, how are we going to write that? Is greater than 76. How would I write that? And we should be able to type that. Okay, Theo, I see you. Okay, do we agree with Theo? Or, I don't even think it's Theo. I think it's Theodonis. I'm just going to say Theo. Just sounds really cool. Okay, greater than or equal to. Oh wait, hold on. Hey Lynette, how are you? So Abba, okay, I see you. Alright. Theo is fine? Okay, thank you. Because all of a sudden I just looked at it, I was like, oh, Theodas. Got you. Okay, Shucky Ducky, I see you. Okay, Dolce, I see you. No, don't flip it around, Yar. Don't flip it around. Okay, so this time, I see you, Grateful. I see you, Star Child. I see you. So now we're talking about is greater than. Now, greater than is when it opens to the back. Okay? A lot of people like to say, think of it as an arrowhead. This is how I learned it. If it's different nowadays, I'm so sorry. But the way it points, if you think of the number line, all your numbers are larger to the right. So greater than points to the right. Okay? So then you're 76. Okay? Alright? So now, let's solve this bad boy. Okay, this is like a one-step inequality, which is kind of cool. Alright, no problem, no apologies. Yes, because sometimes it's always like we forget, like less than kind of looks like a broke down L, if you ever look at it. So what do we do in order for us to solve this? what do we do to solve this? What should I do next? Right? What should I do next? Okay, Theo. Yeah, everyone does with the eating and all that stuff. Okay. All right. So it's not going to be equals. Still keep at it. We're not going to cross multiply. So Abba, I'm going to see if I can get a problem for you. Because this is the second time you said cross multiply, I think. So we want to isolate our x. So we are going to add 23 because that's the inverse of minus 23. Okay. So negative 23 plus 23, that gives me 0. We don't need the 0 as a placeholder because we still have our x to come down. So now 76 plus 23, so that gives me 99. Now, do we change the direction of the inequality sign? You can write Y for yes or N for no. Put that into the chat. Do we change the direction of the inequality sign? Y for yes or N for no? Okay. Dolce with a no, Thea with a no, Shucky Ducky with a no, Sherry Collins with a no. Okay. Because we are not multiplying or dividing by a negative number. Okay? So we just added 23. So my sign does not change direction. It stays exactly the same. Okay? It stays exactly the same. Alright, Abba, do you see it? Okay, you only change direction if you had a negative inequality. So let me show you. So if I said like negative 2x plus 6 is less than or equal to, I don't know, 12? Why not? We'll make it. Alright, so just throwing this out here so you can see it. So if I'm solving this, I'm going to first subtract the 6 on both sides. What comes down is my negative 2x is less than or equal to 12 minus 6, which gives me 6. Alright? So now, I want to get x by itself. So what do? I divide both sides by negative 2. Negative 2 divided by negative 2, that gives me my 1. So 1x and x means exactly the same thing. Now we have 6 divided by negative 2, that gives me a negative 3. Because I am dividing by a negative 2, I have to change the direction of my inequality sign so I can get a true statement. So that'll be greater than or equal to. This would be my answer. Coming regularly? Good. Hello! Oh, it's raining there? Oh yeah, we had a lovely storm yesterday. Okay. That was weird. Sorry. All of a sudden I smell like peanut butter. That was weird. I'm having a stroke. Yay! First it's hot flashes, now I'm having a stroke because I smell peanut butter. Weird. Okay. Alright, what math is this? So right now, we're just basically solving inequalities. So just to show, I know, right? What's going on? Or unless it's a spirit walking by with a peanut butter sandwich. Anything's possible nowadays. Why not? So do you see the reason why we would change the direction of the sign? Anytime when you get close to the end, usually that happens. When you're dividing or multiplying by a negative, you have to flip the direction of the sign. Okay? Sure. Let me see if I can put both of them on the same screen. Okay, so the other equation, all we did was add 23 on both sides. So inequality sign did not change. Okay. All right. So that's going to be, I want to say key. I was going to say cool and clean, but key when you're looking at the SAT, the ACTs, any of those standardized tests. Because just knowing, if you see, once you get to this point and you know you're going to divide both sides by a 2, you know you're going to have to flip your inequality sign. Remember, GED, any of the high school equivalency tests, ASVAT, they're going to show you multiple choice. So this is what you do. We're going to no longer do multiple guessing. Now we're going to do what's called POE, P-O-E, process of elimination. By knowing what to do with inequalities when you're solving, you can get the process of elimination without doing a lot of the solving. Okay? Yeah, I don't do linear programming. Sorry. All right. So, let's do... Okay, I'm staying on a little bit longer today. Why not? Okay, let's do 2 more problems, and then we'll just be resting our brain for the rest, and then I'll just see you guys tomorrow. Okay, try to solve this. I'll even give you like a minute for this one. Oops, got crazy. Alright, try to solve this, or simplify this actually, because there's no equal sign to it. Okay. When will I teach systems? I've taught systems a couple of times. Actually, 2 days ago, or it felt like 2 days ago, I did systems. You're in California? Wow. Okay, yeah, because I come on at 7:45, so that is what, 4:45 in the morning for you? Yeah. I will try to do a afternoon or evening one. I will try. Or if anything, I know I'm going to try my new times, because now a lot of my students are starting to come back, which I'm so grateful for. But I'm thinking about changing my time to, instead of 7:45, possibly change it to like roughly 10. Okay. All right. Okay. Yeah, early in the morning for people. Okay. So, Gamer, I see you. Okay, Big Al, I see you. Yar, I see you. Okay, what grade is this for? Well, this is like Algebra, Algebra 1, second semester, Algebra 2, second quarter, roughly. So, can there be multiple variables in inequality? Yes. You can have it probably at max like 2 is what you'll generally see. But you can. Yep. Okay, got it. So it's okay. It's great. Don't want to do this one. Kind of figure this out. Okay, not a problem. Now, what we have here, and remember when we talked about exponents, okay? So when we said something, let me flip it over for a second. When we said something like x squared, so x squared is the same as saying x times x, right? So if we said x squared, if I said 4 squared, that's just simply the exponent is telling my base how many times it's multiplying itself, which is 2 times, right? So 4 times 4, 16. You're doing the same thing, but this time, instead of a single number, you have an expression. So what we're doing is we're going to multiply that expression, x plus 6, 2 times. Multiply into itself 2 times. Okay? Alright. So now, what we're going to do is, there's 3 different ways of doing this. I'm going to show you 2. So you have your distributive property, as a lot of people like to call it, FOIL. I don't like to call it FOIL because it gets confusing. God forbid if you're a person that don't know how to spell FOIL. I'm not insulting because that's where I was. I would always put the I before the O, and it just, like, is there an I at the end? Foley? So you just heard about one of my problems growing up. So I just like to say, take the first term and distribute to everything inside the second parenthesis. All right? So x times x gives me x squared. X times 6 gives me a positive 6x. Okay? All right? So now we're going to take this positive 6 and we're going to distribute that to everything inside the second parenthesis. That's all we're doing is just distribution. Okay? So positive 6 times x gives me a positive 6x. And a positive 6 times a positive 6 gives me a positive 36. Now, if you told me that the answer was x squared plus 36, that means you're just squaring the x and you're just squaring the 6. Okay? Because we have like terms right here, dead center. Okay? See? Alright. So now, we're going to combine those. So, plus 6, that gives me a plus 12x. So now, exactly, combining like terms. First time Big Al, you wrote that, I was like, what the heck is that? I was like, okay, think about it, Audrey, think about it. I'm like, oh! All right. So AI was right for once, yeah. So now, when it gets here, this is another thing that people generally do. Like a good, I want to say a good 75, okay? People want to say, oh, okay, so I combine the 1 and the 12 and I get 13x cubed. No. When you're combining, in order for them to be like terms, they have to have the same variable with the same exponent. That's why I didn't add the x squared with these two x's. Okay, so I only have like terms with x squared with x squared. So this is your final answer. Okay. Yes, there's no more like terms. Okay. What do you do with the extra terms? You bring them on down. Okay, if you can't break it down, you bring it on down. Okay, like another question. If it's more like x plus 6 over 2, then squared. So something like that, that's order of operation. That's completely different. Okay, so Theo, I saw that. Yep, that's going to be completely different. Alright. Oh, you want it like that? I mean, you can. But are you dividing the x plus 6 or are you dividing just the 6? Okay. So that's another thing. Okay, so you're dividing the whole expression? Okay. Let's see what kind of fun this is going to be. Alright, so that means yes. And if it's squared, you will write it out twice. So you have your x plus 6 over 2, and then you have your x plus 6 over 2. Now, this one, you're not cross multiplying. I think that's what Abby was doing. You only do cross multiplication when you have two ratios. This one you're going to have to multiply straight across and then simplify. Okay. So then you'll have your x squared plus 12x plus 36 over 4. And if you want to simplify that, this will be x over 2 over 4 plus 3x plus 9. If you wanted to take it that far. Okay. All right. Exactly. You made up the problem. So you will multiply the numerators. So the distributive property, just like what we did before. X times x gives me x squared. X times 6 gives me 6x. 6 times x gives me 6x. And 6 times 6 gives me 36. So the numerators is what we got for the factoring. Remember what we did right here? Okay. So that, let's see, that goes in your numerator. Then you have your 2 times 2, which gives you 4. So how did I get this? I divided everything by 4. So what's in front of this x squared is a 1. So 1 divided by 4 is 1/4. That's why you have your x squared over 4. Okay. Then you divide your 12x divided by 4. So 12x divided by 4, that's where the 3x came from. Okay? And then the 36 divided by 4, that's where the 9 came from. Okay? All right. There we go. All righty then. Okay, so for our last problem, it's going to be a word problem. You're like, what? Why? Because they exist and we cannot ignore them. All right. So here's the last part. Take a look. Take a look. You're probably like, nope, don't know it. Because I used to be the same way. I would say the same exact thing. But I'm going to show you. Okay? Not a problem for you. Not a problem. Okay? So, as soon as we see words in a test, and this is why they put a lot of word problems on exams. They try to separate the haves and the have-nots. Okay? So when you see a word problem, 1, take a breath. 2, what are we trying to find? What is the question? So they're saying, find a simplified expression for her profit, and they gave us an equation. So they're saying the P of H equals, so P meaning profit, okay? And they're saying the profit, they're saying the R of H. So R, if I look right here, is my revenue, and they're giving me an equation. Minus the E of H. E of H is their expenses, and they gave us another equation. Hey, Janice. Yeah. All right. So they want us to find a simplified version of P of H. So they're saying they want us to take the R of H and minus the E of H. So what's R of H? Well, the R of H is your 75 H plus 100. They told us right here in the beginning. Okay. Now they want us to subtract what's going to represent our E of H. And what did they say is representing my E of H? Put that in the chat. What's representing the E of H? What needs to go here? What needs to go in for the E of H? Okay. Yeah, it's the 15H plus 30. Good. The 15h plus 30. Excellent. So we got our 15h plus 30. Alright, good, Theo. Good shot. Big G Money, how are you? Alright, so now I'm going to pull this aside. We're going to focus up on this. All we need to do is to simplify this. So this is the part, just woke up, that's okay. This is the part that throws a lot of people off. We're not worried about the P of H. Almost like ignore that. Let me grab a sheet of paper. Ignore that part. We're just going to focus on this. So we're subtracting these two things. So let's subtract our like terms. So we have 75h and we have 15h. So what's 75 minus 15? Okay, so Shah saying 60. Okay, we agree? Because I do. There we go. Good. So that means 75h minus 15h gives me 60h. But this is the part that everyone thinks that, oh, I did my subtraction with the 15h, so then the subtraction goes away. No. Okay? Now you're doing your 100 minus 30. So it's not going to be 130. We're not adding the 100 to the 30. We're doing 100 minus the 30. There we go, John. All right, so that gives us a positive 70. Right? So that means the expression that they're looking for to represent the profit is going to be this. Okay, I can hear it from here. That's it? All that? All this writing just for that? Like, yes, that's it. Okay, that's all they want. Now, another way of approaching it, because this is what's called subtracting polynomials. So another way of doing it, so we have 75h plus 100 minus my 15h plus 30. Since our brain naturally goes to addition, we can do what's called keep, change, flip. We're going to keep this first expression. We're going to change that minus to a plus, and then we're going to flip all the signs in the second parenthesis. Okay? So if you want to, so you have your 75, that stays the same, 75h plus 100. Change that minus to a plus, and then flip all your signs. So now this is a negative 15h, and this is also a negative, but a negative 30. So you can make sure you're getting the correct signage. Our brain does well with adding things. Our brain does well with grouping things. That's what multiplication is. It's fast addition. You're just grouping. It doesn't really care for subtraction because think of it. When you have a baby enjoying something, a bottle, a toy, whatever, and you take it out of the child's hand, what's going to happen? That baby's going to cry, lungs, I don't even know. People in the Himalayas can hear it, right? And you're like in Baltimore, Maryland. So anything being subtracted, anything that, oh, we need to divide this up. They don't like it, but they'll do it. That's called sharing, right? So because of those things, sometimes people have these little tricks. of, hey, like keep, change, flip. So now you know how to do your 75 plus a negative 15. You're really doing subtraction because the signs are different. That's how you got your 60H. And then you have your 100 plus a negative 30. So when the signs are different, you're really subtracting. That's why you got a positive 70. Okay? Just a different way of doing it. Okay? Same thing. Alright? Just so to make sure that you get your right answers. Alright, ladies and gentlemen. I'm tired. I gotta go check on laundry, vacuuming, check on the cats, because God knows what they're doing. Way too quiet in this household. Not a problem. So, for right now, I'm not sure if I'm going to be here this afternoon, but on Sunday, I'll be here at 7:45. But on Monday, I am going to be able to come on at 10 o'clock, 10 a.m. I'm going to try, because now that my kiddos and some additional tutoring clients are coming in, so I know my hours are going to have to change, and I don't think I'll be able to do tutoring and be cohesive at the end of the day. So I know I'm probably going to have to make a couple changes because school's back in session. But if you like these, oh, thank you, Mary Pat. I appreciate you guys so much. Awesome. So if you like how I break these concepts down, you're looking for reasons, and you need additional assistance for your GED, for your ASVET, for your Accuplacer, all right? If you go ahead and follow me first off. So if you go and you look right here where it says Stand Store. So I have a lot of resources, and if you click on that, there's a couple of things that I would love for you to do. One, if you want to do some more practice, I have a free math checkup. It touches on various parts that you usually see in the GED. Maybe you can use it as an algebra refresher. You can use it for homeschool parents. You knock yourself out. And if you want me, because there is an answer key, but if you're just like, how did she get that answer? You can take a picture of it and send it to me. Send it in my DMs, okay? I'll take a look at it, and then we'll chit-chat about it to see if you're on the right spot, all right? No one has taken advantage of that. Do you think I'm not human? I am human! So you can definitely do that, all right? Now, the other parts, if you want to, I have all these other programs that I do that will help you break down these concepts. It's called Algebra at Your Pace. So these are the individual books. So if you're thinking about like just starting from the very beginning and you're getting ready for your GED, the ASVET, or the Accuplacer, and you definitely have more than 2 weeks, take a look at some of the books, okay? If there's a section that you're just like, ugh, I don't know what that part is, well then maybe it's factoring, because we did some factoring today. So if we come all the way down to factoring, right here, about to pass it. Okay, so volume 7 and 8. If you need more practice with factoring, what it does is I have a video recording of myself breaking down several different types of factoring, give you some practice problems, give you extra practice problems, and a summative quiz at the end of the book. So if you want, you can go ahead, scroll, have fun with that. But then here's another thing. In between the F and the IN is my YT channel. So if you're, okay, I was like, oh, fat fingers. Okay, if you ever want to, you can go ahead and subscribe, and you can see a lot of my videos. So here we go, TikTok Lives, uncut, because I'm not editing this stuff. This is crazy. Today's is probably going to take me about probably like noon, because it takes forever to download. But this will give you a notion of like all of my videos that I have here, that I created, all my lives that I created here. Okay? So if you have any questions, please, if you have a question, don't be afraid to ask it. I don't want you to ever feel Audrey's going to judge me. That's not what I'm here for. I've been judged throughout my whole entire life and probably still going to be. And I don't want that feeling to be put on anyone else. I remember as a student, I struggled. I wish I could have this when I was a kid. You know? Prime example. Okay, so I wish I had this when I was a kid. And now I know a lot of us are starting to get into some math problems that either you have never seen, but it's on a test. Okay, that makes sense, right? So that's why I come on here and break down certain concepts. Sometimes I just do one thing, sometimes I mix it up. But if you do have questions, please ask them. Don't think, oh, it's a stupid question. No, exactly. I can't go without asking my questions. Exactly. Okay? So please take a look at it. That's why I created that. I stay up many nights creating all of these things for you. And if you want any of my cards, they're on sale as well. I'm going to have to speed flash it. Just close your eyes for like 2 seconds. 1, 2, okay, maybe longer. 3, 4, 5. So we get closer to the bottom. If you want just practice books, I have one for GED, ASVA, and Accuplacer. It's 6 full books or 6 full tests in there that you need to practice the way you're going to assess. The same thing for the ASVAT. Okay, I have a book for you guys, but then I extended it. I also added the video solutions. So now you really can learn independently, and if you ever get stuck, you can message me. If you go to the very top of the stand store, you can send me an email. Look at us communicating. Alright, so if you want any of the flashcards, okay, so the verbal flashcards, that's right here. Any of the order of operations, which I didn't do too much today because I wanted to do a little bit more with the solving. But I have like flashcards, okay? I have reference sheets. I have multiplication and dividing. So you think about it. Scroll. Have fun scrolling. But if you want these in physical books, you have to go to the A, okay, in order to get it, okay? Oh, thank you, Shucky Ducky. Appreciate you. Okay, so that's the same thing about all the cards, even with some of the exponents, exponential cards, okay, that comes in book form. So this side is the question, this side is the answer. So anything to best support you, your child, your classroom, let's go. Okay, because we don't have to, reinvent the wheel. You got a person that can help you out. All right? So make sure you follow me here, as well as if you want to take a look, just go to the stand store. It's the only link in my bio. All right, and I also have like a couple videos here that I have on my listing. Alrighty. Alright, everyone. So I'm going to go and be Audrey mode and start cleaning my house and, grocery shopping and all that fun stuff. Yay, life. You gotta love it. But again, if you do have any questions, do not hesitate to ask. Alright, everyone. Have an amazing day. And I'll probably just see you guys tomorrow morning at 7:45 Eastern Standard Time. And we're going to do some more work. Alright, talk to you soon. Bye now.